Have you ever pondered what everything around you, including yourself, is truly made of? Welcome to the intriguing world of matter, the very fabric of our universe. From the air we breathe, to the ground beneath our feet, from the food we eat, to the stars that twinkle in the night sky, everything is composed of matter. Matter is an incredibly diverse concept. It's in the solid form of the chair you're sitting on, the liquid in your morning coffee, and the gas that fills the air around you. It's in the plasma of the sun that lights up our world, and even in the mysterious dark matter that we can't see but know exists. But what is this matter that we speak of? At its simplest, matter is anything that has mass and occupies space. It's a basic principle we've all learned in school. Your favorite book? Matter. The water in the oceans? Matter. The air we breathe? Yes. You guessed it right, it's matter too. Yet matter is not just about mass and volume, it's a lot more complex and fascinating than that. Matter is composed of tiny particles called atoms, which themselves are made up of even tinier particles known as protons, neutrons, and electrons. And these subatomic particles hold the key to understanding the true nature of matter. But here's where things get really interesting. You see, these particles aren't just tiny specks of stuff, they're also waves. Yes, you heard that right. Particles and waves, two seemingly distinct concepts, are two sides of the same coin in the quantum world. This is the enigma, the paradox that lies at the heart of our understanding of matter. It's a concept that has baffled and fascinated scientists for centuries. And it's what makes the study of matter so incredibly exciting. But what if I told you, the essence of matter goes beyond just mass and volume? In the upcoming scenes, we'll dive deeper into the microscopic universe, the quantum quarks, and the theory of everything to unravel the ethereal essence of matter. So buckle up and get ready for a mind-blowing journey into the heart of the universe. Diving deeper into matter, we find ourselves in a microscopic universe. Here, matter is not just a solid chunk of stuff but a bustling metropolis of particles. At the heart of this universe are atoms, the building blocks of matter. These atoms are so small that millions of them could fit on the head of a pin. Yet within each of these minuscule entities, a world of complexity unfolds. An atom itself is composed of even smaller particles, protons, neutrons, and electrons. Protons and neutrons huddle together in the atom's nucleus, a dense core at its center. Protons carry a positive electrical charge, while neutrons are electrically neutral. On the outskirts of this nucleus, in a cloud of negative charge, the electrons orbit. These tiny particles, over 1,000 times lighter than either a proton or neutron, carry a negative charge. This negative charge balances out the positive charge of the protons, giving the atom overall electrical neutrality. But here's where things get interesting. These particles don't just exist in isolation. They interact, forming the essence of matter. The protons and neutrons bind together by the strong nuclear force, one of the four fundamental forces of nature. This force is so powerful that it overcomes the repulsion between the positively charged protons, keeping the nucleus intact. Meanwhile, the electrons are held in their orbits by the electromagnetic force, another one of nature's fundamental forces. This force attracts the negatively charged electrons to the positively charged nucleus, keeping the electrons from flying off into space. These interactions between particles provide the structure and stability of atoms, allowing them to combine and form the diverse array of matter we see around us. So when you touch something, you're not really touching it. Instead, you're feeling the electromagnetic force of the electrons in your skin repelling the electrons in the object. Yet the story of matter doesn't end here. In the realm of the extraordinarily small, quantum mechanics takes the stage. It's in this fascinating world that we delve into the essence of matter, beyond what we can see or touch. Quantum mechanics, a theory that has revolutionized our understanding of the microscopic universe, is our guide into this realm. Let's start with the basics. Quantum mechanics is a fundamental theory in physics that provides a description of the physical properties of nature at the scale of atoms and subatomic particles. It's a mathematical framework that is, in many ways, different from the classical physical theories we're familiar with. One of the most intriguing aspects of quantum mechanics is the concept of wave-particle duality. This is where things get a bit mind-bending. You see, electrons, those tiny particles that orbit the nucleus of an atom, they don't behave like particles all the time. Sometimes they behave like waves, spreading out and interfering with each other. It's as if they're in multiple places at the same time. This duality, this ability to be both a particle and a wave, is a fundamental aspect of quantum mechanics. Then there's the Heisenberg's uncertainty principle, another cornerstone of quantum mechanics. It states that you cannot know both the exact position and momentum of a particle at the same time. The more precisely one measures one quantity, the less precisely the other can be known. This isn't due to any limitations in our measurement techniques, but rather, it's a fundamental feature of the quantum world. So what do these quantum quirks tell us about the essence of matter? They tell us that matter, at its most fundamental level, is not solid, not stable, not even always predictable. It's a swirling, dynamic, probabilistic dance of particles and waves existing in multiple states at once, until observed. It seems, the essence of matter is not as simple as it initially appears. Indeed, in the quantum realm, reality is far stranger than any fiction we could devise. But it's this very strangeness that makes quantum mechanics such a rich and fascinating field of study. On our quest to understand the essence of matter, we encounter a grand theory. This grand theory is none other than the theory of everything. Now you may be wondering, what exactly is this theory all about? Well, it's a hypothetical framework that aims to tie together all physical aspects of the universe into one comprehensive and harmonious picture. Let's dive a bit deeper. The theory of everything is essentially a theoretical framework that seeks to reconcile two major pillars of modern physics: quantum mechanics, which describes the behavior of the tiny particles in the quantum realm, and general relativity, which describes the behavior of massive objects and the structure of space-time itself. Imagine a vast tapestry with threads representing the laws of physics. Some threads represent the quantum world, while others represent the world of general relativity. The theory of everything aims to weave these threads together into a single coherent fabric that depicts the essence of the universe. Yet this is no simple task. The quantum world and the realm of general relativity are like two different languages, each with their own set of rules and structures. They describe the universe in fundamentally different ways, making it challenging to establish a common ground. The beauty of the theory of everything lies not just in its ambition, but also in the profound implications it holds. If we could unify these two theories, we could gain a deeper understanding of the essence of matter and the fundamental nature of our universe. We could potentially unlock secrets about dark matter, black holes, the birth of the universe, and so much more. However, despite decades of research and countless brilliant minds working towards this goal, the theory of everything remains elusive. There's still much we don't understand and many puzzles left to solve, but this doesn't mean we should stop trying. On the contrary, it's this very challenge that drives us forward. Although the theory of everything remains elusive, it represents our relentless pursuit for understanding. It's a testament to our curiosity, our determination, and our unwavering commitment to unravel the mysteries of the universe. Our journey into the essence of matter has been nothing short of extraordinary. We've journeyed through the enigmatic nature of matter, delving into the depths of the physical world to understand its fundamental building blocks. We've seen how matter, which makes up everything we know and see, is not as simple as it initially appears. It's an intricately woven tapestry of particles, each with their own unique properties and behaviors. Our exploration took us into the microscopic universe, where we discovered that matter is composed of atoms, which are themselves composed of protons, neutrons, and electrons. These particles, though minuscule, play a colossal role in defining the nature of the universe. From there, we ventured into the realm of quantum mechanics, a field of study that defies our everyday understanding of the world. We learned about the quirky behaviors of particles at the quantum level, where they can exist in multiple states simultaneously and influence each other instantaneously over vast distances. Our journey then led us to the theory of everything, an elusive yet intriguing concept that seeks to unify all known physical phenomena into a single theoretical framework. This theory, though still a work in progress, is the holy grail of physics, promising to provide a comprehensive understanding of the universe's workings. So, what have we learned from this journey? We've learned that the essence of matter is far more complex and extraordinary than we could have ever imagined. We've learned that our understanding of the universe is continuously evolving as we push the boundaries of human knowledge. And yet, despite our incredible progress, there is still so much we do not know. There are still mysteries to be solved, puzzles to be pieced together, and questions to be answered. But that's the beauty of science. It's a never-ending quest for knowledge, an eternal journey into the unknown. While we may not fully comprehend the essence of matter, it's clear that our understanding is constantly evolving, pushing the boundaries of human knowledge.